Welcome back to Project KIRA. This is a collaborative speculative biology project that all takes place on the Project KIRA Discord server. Last time, we covered the true fused body creatures that stemmed from conflated corpusca, or fused body, during KIRA's Cambrian Explosion. But we aren't done with it yet, as it is now time to dive into the various clades of the false fused body creatures. Unlike the clades of conflated corpusca, the clades that we are going to talk about today did not immediately develop fused bodies. Rather, they stayed segmented, only fusing body segments when it served as a more advantageous adaptation. The father of this clade is Oceanusfalsusvermisa, or ocean falseworm. These predatory aliens are considered to be the start of the Cambrian explosion, as they actively developed predatory lifestyles. Oceanusfalsusvermisa stems from Vitis primoscura. It has many predatory adaptations that allow it to become some of the top predators of its early times. It preys on primoscura and later Piscis pinnatura, using a tail for mobility and fins for stability. When pursuing prey, it launches itself towards the selected prey item. If the initial launch is missed, the skin-stretched membrane of the tail can act like a barrier, getting in the way of the escape and offering a second chance to strike. This, however, is only a behavior that is found in a small number of individuals. Different color variations exist between species, but most common is the shades of blue and purple. This allows it to hide from its prey and its very own predators, as, despite the ferocity that they may display, they are quite small. They have also developed a shell-like armor to protect itself from other ocean predators like Dentatus natatura. The gills of Oceanusfalsusvermisa have also changed in location. Rather than being on the sides of the body behind each fin pair, their gills now sit atop of their heads that look like feathery appendages. There also seems to be an increase in the number of body segments, but for what purpose is unknown. Shortly after the rising of Oceanusfalsusvermisa, a variant would soon split off that would become Eel Cyclops, or finned cyclops. These aliens tend to stick to the ocean surface, eating creatures that are smaller than itself. Like its ancestor, Eel Cyclops waits for its prey and then charges towards them. This is the only practical hunting strategy for these one-eyed aliens, as they have very poor vision. This hunting style is further complemented with the fusing of the body segments. But the loss in eyes and body segments aren't the only things this creature has lost. It also has seen a reduction in the number of fins, now just relying on one pair of fins and its caudal tail. The jaw structure also seems to have changed direction, moving in a sideways-like motion similar to the feeding appendages of Dentatus natatura. Eel Cyclops come in a variety of green hues, ranging from pastel green to sometimes bright lime green, though the latter is more typically rare. Armatus procopisca, or armed longfish, is the next clade in our list. They have evolved from Eel Cyclops in a surprisingly negligible amount of time compared to the other aliens of this time, which is saying a lot. The pair of fins on Eel Cyclops have been adapted into simple arms, going so far as to even evolve digits to help grab. There is also a visible dorsal fin that runs down the aliens' backs and heads. The sideways jaws of its ancestor has once again re-evolved into a pair of jaws that move vertically. It is thought that Armatus procopisca evolved after a certain group of Eel Cyclops found success when hunting near the surface of the sea. This conclusion was made when it was noted that some groups have developed internal lungs made for respiration in the air, taking in atmospheric oxygen. However, once again, this is in a rare few individuals. Following the emergence of Purpura foliama, a clade of purple photosynthetic organisms that we'll talk about in Part 4, clades that specialize in green hues like Eel Cyclops and Armatus procopisca quickly began to go extinct for not being able to camouflage properly. But their legacy will not be entirely lost, as a group of Armatus procopisca have not only evolved to camouflage with the purple flora, but have also used it for hunting, becoming one of the first clades to ambush hunt. Similar to the frogfish of Earth, this new clade of aliens has evolved to hide especially well in the purpura botrusa. They lie in wait for small prey like Piscis penenatora and Primascira. Once potential prey items are close enough, they will use their arms to launch themselves forward, clamping their massive maws onto the unsuspecting victim. Interestingly, due to their solitary nature, both males and females of the species are capable of having and caring for young. They do this by keeping their young in their massive mouths, protecting them until they are too big to live there anymore. The offspring gain nutrients by feeding on the prey that is captured by the adult. Some species are specialized enough to have developed a special birth pouch to better ensure the survival of their offspring. I'll dub these creatures Armatus fictissa, or armed fake, for their ambush tactics. Hope for the dying clades of Cyclopsa is once again given in the form of Purpura angula cyclopsa, or purple eel cyclops. As the green Cyclopsa slowly but surely got hunted into extinction, no thanks to the purple flora that soon filled the seas, one random genetic mutation would end up saving the group itself from complete extinction in these early seas. A group of open water dwelling Cyclopsa developed a purple pinkish coloring that helped them blend in with the aquatic foliage. This new clade would be slow to expand at first, being restricted to only a dozen species as maximum. However, with the development and proliferation of the piscis groups across the oceans, these creatures further specialized to specifically hunt the Piscis penenatora. With this, they exploded in diversity, with species living wherever piscis could be found. A very small number of these eel cyclops hunt in groups, although the majority are solitary and so hunt alone. They are capable of swimming down the prey at high speeds due to their highly effective angular form locomotion, assisted by their massive fin tails and sharp fins. Their mouths have also adapted onto holding onto their prey with their surprisingly strong jaws, especially given that members of this clade don't generally grow bigger than an earth moray eel. Metaphorical amendments would be made between these cycloptic eels and purple algae when a group of purple eels would make a symbiotic bond with some of the purple algae. Scopulum anglia, or reef eels, are found on reefs or heavily vegetated / floral environments. These herbivores have been found to grow the vegetation that they eat on their bodies, making them the first aliens on KIRA 30 to actually incorporate photosynthetic organisms in and on their bodies. This algae symbio serves as camouflage and as a meal for these reef eels. This partnership is believed to be based on the reef eels providing a mobile home which gives them access to flowing water and a secure structure to live on. In return, reef eels are allowed to eat their purple back gardens, possibly also receiving a small amount of glucose that the algae makes. The reef eels themselves have taken the fins of their ancestors and convergently become limbs, similar to the previously talked about clades. Reef eels come in a variety of browns and yellows, with white eyes sitting in the middle of their heads. Their eyes are specialized to see better by having two pupils, one regular pupil and one ring pupil that surrounds the regular pupil. They reproduce sexually, with females laying up to 100 eggs at a time in secure holes and crevices. However, these reef eels and their algae symbionts wouldn't be the only ones to make a symbiotic relationship. This next beast evolved directly from Oceanusfalsusvermisa. Being pressured to evolve from the torment of an alien parasite, another clade we'll get to in a later video, it evolved to deal with them in a very unconventional way. This was done by willingly providing nutrients to the parasites to survive their destructive gestation process. Its old, hard shell changed shape to be more open and cylindrical-like, while using their muscles to keep it all together. Their gills have become hardened horn-like structures, but still allowed the creature to respirate necessarily. It also lost its fins and its double net-like tail due to its new and unique relationship with these parasites. Once the cooperating parasite finishes its gestation, it will cling on to one of the two front teeth of its draconic hosts. These teeth have a patch of sensitive cells that, when touched, activate a signal that's sent to the dragon's brain, telling it to open its mouth and let the parasites crawl out. The strongest of the young parasites go towards the back to help drive locomotion. In further specialization, the parasites that end up in the front will alter their anatomy and end up becoming wing-like appendages that grow out of the host and help with stability. Thanks to this unusual evolution, I will dub these sea serpents Cooperante Mare Dracoa, or cooperative sea dragon. Following the descendants of our cooperating sea dragon, this next clade of dragons has forgone the old symbiotic relationship that they once had. As a result of this development, they have become a lot slower than their ancestors, so in a brilliant move, they changed their hunting strategy from being active pursuit hunters in the open oceans to ambush hunters in the Purpura stipula forests. There, they hunt species of Pinna vermissa and Primuscira by hiding in abandoned dens of burrowing worms. They retain the ancestral segmented armor, but have adapted their horned gills to reduce drag in the water and prevent damage when hiding in burrows. They have also taken on a mostly purple coloration to better blend in with the purple stalks that make up its habitat. These creatures will be dubbed Insidiae Dracoa, or ambush dragon. While this clade may be small right now, they will catch up to their distant relatives in both numbers and in uniqueness. And so, with that, it would seem that we have reached the end of today's video. Thank you so much to the people who have helped contribute to the project for this video: Blue Basil, Sohan, Zon, Harry Knight, and Azure Sky. Thank you to you, the viewer, for watching. Episode 2 has nearly reached 1,000 views, which is 3 times as much as my previously viewed video. Y'all's support means a lot. And if you'd like to help further this project, a link to the Discord is in the description. Talents of all kind are welcome. And in honor of the project reaching almost its half-a-year mark, as well as the holiday season, we will be hosting a cooling event as KIRA 30 dries up and cools down. Hope to see you there. Master Taxonomist White Glove, out.